Yeah. So where you stop? So that LC oscillation, you understand, right? Why exactly the oscillations are occurring?
Yes.
So I have one more question. So I will ask the. So let's say I have one low pass filter. So here is V out and here is V in. I am imposing a square wave, okay, with some 0 to 5 volt. So here 30. Uh, can you draw the waveforms for these two cases? First one is T is very, very greater than tau. Second one is T is very, very less than tau. Can you quickly draw the waveform? Like V output voltage for two cases.
Yeah. For T very greater than tau, we know that there is enough time to reach its steady state, right?
Hmm.
So let's like outline of the input.
Hmm.
So it will reach its steady state like here.
Hmm.
Like initially, the capacitor was short circuited. Like there is a infinite. Signal acts
Oh,
as an infinite frequency,
okay.
so it will rising its voltage to 5 volts,
Oh,
and
okay.
then it equal to T by 2 plus. There is a again the capacitor was short circuited, but it's holding the voltage of 5 volts,
Okay.
and there is a current which is flowing outside the capacitor. That means there is a
Hmm.
discharging of the capacitor,
Okay.
like here. So
Yeah, it's
again
fine. It's fine.
the
I think
this
you got
process was
the, yeah, I think you got correct way. So that's fine. That's fine. I think you got the good concept here. So then can you quickly draw for second one?
uh, during second case.
Yeah, yeah. Can you try to follow my page here, whiteboard?
I am
So,
I am following.
okay, fine, fine.
In second case, the time period is very less, or the RC is time constant is high.
Hmm.
So circuit can reach its steady state within the T by 2 window.
Okay.
So it reaches to some value. So initial current is 5 by R.
Hmm.
At T equal to 0, the capacitor short
Hmm.
circuited and 5 by R amount of current is flowing.
Hmm.
So it is the T by 2, right? So it will just charge linearly, irrespective of it reaching its steady state. So at this point, let's assume
What?
there
Wait,
is
wait,
a
wait.
voltage,
Linear. Is it linear?
not linear, not it exponential.
Yes. Okay. But it is not reaching final value, right?
Due to its large time constant, it looks like linear, but
Okay.
it is
Okay. Okay.
exponential.
Okay. Fine. Fine. Okay.
Uh, at this point, for example, can I write this equation, right?
Yeah. Okay.
Or
You can write.
at
I
this
think you
point, the
can.
value is
Yeah. Yeah. Okay. You can directly write the sample graph only.
mm,
Fine. You can normally write the
5 of
graph.
1 minus
I
T
think
by
better
2.
you don't go for equations. You can write the graph only. Like for
Okay.
a lot of
At
cycles,
this
you need to
point,
write.
okay, let's
Yeah. Just tell the
scroll.
how the graph look like and how it is reaching
Just to,
steady state. Just tell in terms of graph only.
just to scroll right way. Scroll left. Okay. At this point, right? Uh, for example, it's just charge up to 2 volt. So then
Hmm.
what is the current is flowing? 5 minus 2, right? 3 by R. So during discharging, but it's flowing in opposite direction.
Hmm.
So it will discharge.
Hmm.
Discharge with yeah 2 by R current, which is not equal to charging current, right?
Okay.
So it will discharge to some value other than 0. It will.
Okay, okay, okay.
Capac
Yeah.
capacitor was thinking to reach zero, but it can't reach zero.
Fine, fine. Okay, fine.
So again, it will reach to somewhere.
Okay. Okay,
Like
with some
it will
like
reach the
it
steady
looking
state.
like some initial conditions you were saying.
Yes. Yeah,
So
at
what
steady
is
state, it
the
will reach.
yeah, yeah, right. Can you just draw the steady state waveform here? How it will look like down?
Steady state 5 volts, right? It has a DC value of 2.5.
How it is DC value is 2.5? How it came to 2.5?
Because at this point only charging rate was equal, or RC circuit is access low pass filter now.
Okay.
So definitely the 2.5 is come due to
Why?
DC value.
Why 2.5? Why not 3? Why not 4?
Okay, let's assume it has a DC value of 2.5. We know
Where
the
it is
transfer function like
why it is having
here
DC
now.
value 2.5 for this circuit? How?
By calculating the average value, like
Yeah, okay. How you are calculating average value?
by knowing area of one time period by total time period.
Okay, so I given time period only. How you are getting to know this is exactly 2.5 average?
If this period is equal to this period, then the value is 2.5.
Yeah,
Or
that is
else,
yeah, that is true. But I haven't given the I haven't given these two are equal, right? So without that
then
condition, how you are saying then?
so 2.5 or not the that having the some value of DC, right?
Yeah, what is the value of DC? I'm saying.
It's based is based on its time period. If you give this time period, or you can
Yeah,
find
yeah,
at
yes,
steady
yeah.
state, you can also find at steady state.
Okay, how you are going to find in steady state for this input? Tell me.
At steady state, the capacitor was open circuit, right? Nothing but the
Oh,
average current flowing through the capacitor was zero.
okay. See, simply current is zero. You are saying. Okay.
No current. The average current is zero.
Then
So by using some equations, we can.
why? I want intuition also. I am saying you are saying it will stabilize some DC value, right? So
Yes.
how you got to know the DC value is 2.5 only? Why not 3? Why not 1? Why not 4? How you are calculating the value? How you are saying 2.5 only DC?
Because at 2.5, the charging rate, uh, charging current is equal to discharging current.
How? Why like that? If you are saying 2.5 is DC, then definitely I agree. A DC charging and discharging need to be same. But I am
Yes,
saying
yes,
DC is 3, then definitely the charging discharging rates are equal at 3, right? So
yes.
then how you are saying 2.5 is a DC value? First we want to find DC value. Then we can say, okay, at DC value, charging and discharging rates are same. Without knowing DC value, how can we justify? That is the point where we get charging discharging are same.
I will just assume this time period equal to this time period, so automatically the value is
Okay,
2.5.
okay.
So
Yeah,
I
yeah.
assume like
Oh,
that.
you assumed this time period equal to this time period, then duty
Yes.
equal to
Uh, Duty cycle 50%.
yeah, okay, okay. So let's say my question is like I haven't given any information regarding D actually. So without information of D, we cannot justify anything, right? So I am giving now duty equal to 0.6, let's say 60%. Now can you draw the steady state equation for this circuit?
Yeah, yes.
Steady state graph, can you draw this one? Where the DC value will settle and how it will look like.
If it is 60% means
Hmm.
there is a DC value that is greater than 2.5, definitely.
Then what is that value exactly?
Just do some rough work. Okay, so the period 0.6 times of the time period having the positive cycle, right?
Correct, correct.
Okay, P1. P2 equal to 0.4 into T. So by this we can simply get the average value like 0.6 into T into 5 divided by T by 10. So it is having the DC value of 3, right?
Yes, yes, correct. Okay, can you draw the graph now? That is correct.
Okay, it's steady state only.
Yes, steady state.
Steady state having the DC value of 3
Mm-hmm.
and having the ripples.
Okay, okay.
Ripples. These ripples can be eliminated based on the R and C values.
Yeah, okay, that's fine. That's fine. I got it. So, yeah, okay. Input square wave, duty equal to 0.6. That is the DC of input. So, so you are saying the final DC value is stabilizing at 3 voltage because
Yes,
that
3
is
volts.
the DC composition input for the input signal you are saying. Okay, no, okay, fine now. So, my question is why the circuit is stabilizing at 3 voltage only? Why not 4 volt, 2 volt, or whatever other voltage? What you said is correct. Okay, I agree. DC is okay. DC you got from mathematical calculations. I want to know how circuit is getting to know exactly. That is the DC value. We are not saying to circuit, right? We know because we know input signal everything, so we can calculate that is a DC. But how a circuit is getting to know? I need to stabilize at 0.6%, let's say 60% of 5 volt, mean 3 volt. I need to stabilize at 3 volt only. Why? Okay, let's say how it is achieving that state, first of all. Initially, it is starting from some point and it is achieving to 3 volt. And when it is achieving 3 volt, it is stabilizing. Correct?
Yes,
Correct, Tara? It is initially starting from
yes, yes.
zero. Fresh it is starting from zero. Slowly, 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 as you said, time period is very less compared to tau. So, okay, total time is very less compared to tau. So, it is not getting enough time to settle either final or initial value. So, with some initial conditions, it is increasing, decreasing, charging, discharging. And finally, it settled to 3 only. I am saying why it is settled to 3 only, finally. Why it is not settling at 4 or 2 volts. Even though initially it is starting from 0. How the circuit is getting to know? 3 volt only I need to settle. I want that one.
Because at this point the charging current
Hmm.
and discharging current is equal now.
Charging current and discharging current.
Or charging, yes, or charging rate. Initially we only see here where the marker is placed, having the
Hmm.
5 bar amount of current.
Okay.
At this point, 2 by R amount of current. So
Hmm.
here, compared to this, our
Hmm.
charging rate is directly proportional to flow of current.
Hmm.
If you see as the increasing, the charging rate was decreasing or flow of current is also decreasing.
Okay, okay. Okay, you are saying simply charging rate and discharging rates are same.
Or if
So,
you
uh,
do the frequency analysis,
okay.
like So let's assume it is the ideal low pass filter only
Hmm.
pass the DC gains only. If you see this point,
Hmm.
the DC value, whatever the DC value, is only
Hmm.
passing.
Okay.
Either 2 or 3, or whatever in
Okay.
there,
Hmm. Hmm.
that will pass.
Okay. So what you said, it is correct only in terms of frequency analysis. We can able to justify the DC. I agree, but we cannot able to justify full transient analysis in the periodic steady state using the frequency domain analysis. So
Yes,
what you said is correct. From the frequency analysis, we can say it is a low pass filter. It is only pass DC value. If you see the input, it is having DC as 3 volts, so it is only passing 3 volt with some ripple. Anyhow, that will come because of RC. Okay, this is one way of understanding that is good actually. But so even though if you are using frequency analysis also, we cannot justify your full statement, right? I'm saying like what you said was one point, the charging rates and discharging rates are correct. So that is actually a very valid point. So whenever the charging rate and discharging rates are equal, then only system will go to steady state. Correct, right?
yes,
Steady state
yes,
means it is not changing. So whenever charging and discharging rates are same, then the DC remains same. Means it is achieving steady
yes,
state. Correct, right? So
yes,
the
yes.
my question is now, why the charging rates and discharging rates are same at 3 volt only? What you said is correct, absolutely correct. I agree. Whenever charging and discharging rates are same, then only it is in steady state. I agree. That is correct actually. Now my question is, why charging rate and discharging rates are same at 3 volt only? Why not 2 volt? Think. Means something is happening inside the circuit at 3 volt. Just think about that one. Something is happening in the circuit at the 3 volt only. Think in terms of circuitry. Like just see what exactly is happening. Voltage, in terms of voltage, what is happening? In terms of current, what is happening? Something is happening in the circuit. I want intuitive way.
Because
Yeah,
it
tell.
revolves the average current, right?
Hmm.
The average current flowing to the circuit was zero.
At 3 volt?
Yes, at 3 volts, the average current flowing through the circuit was zero.
Yeah, I think you are very near now. That is also correct answer actually. So when we say a system is in steady state, let's say capacitor is in steady state, right? Not a capacitor, output is achieving steady state. That time charging and discharging rates are same means whatever the charges are flowing to capacitor and whatever the charges are going out to capacitor will be same definitely. So then average current will become zero. That is correct actually. Because whatever charging, whatever discharging, it is same for the capacitor. So you are balancing the capacitor because it is in steady state. Because
Yes,
charges need to be conserved, you are saying, right? Conservation of charges. So, because of average current equal to zero, it is going at the 3 volt. But yet, why at 3 volt only average current is going to zero? What you said is correct. I think you are very near to the answer. Current is correct. Average current is zero. But why at 3 volt only? Average current is going zero. Why not 4 volt or 2 volt? Something you need to think in internal of the circuitry. Something is happening in the circuit. Some parameter is saying for that one. Some parameter is saying we achieve steady state. Someone is saying, I want to know what is exactly happening inside the circuit. Which one is saying that one?
the resistor, right?
Not about element actually. I'm saying about some voltage or current, whatever. Resistor and capacitor are just normal elements, right? Just okay. Uh, but I think you almost I think you 90% is completed. Like 90% of the answer you got actually. That is very good. So you You are thinking in different terminology, in frequency terms, in capacitor charge balance. So a lot of different terms you are thinking. That is very good. Almost 90 to 95% you got the answer. Remaining 5% is there. I hope you will soon get. So just think yourself and take whatever time you want. So take some time, and after this interview, you can think about yourself how exactly it is
Okay.
getting. I won't tell the answer, but think about yourself. Think you. You only think you will get to know. So and from this interview, I got some feedback for you. Like Anuj already went because has some work, so I am proceeding for this one. So
Okay.
what Anuj feedback is, you started very good actually. So when he is trying to confuse you, after you confusing, you are trying to give the answer that we observed. He is saying the same thing. You started very nicely, but when you confused, right, you are not saying like you are actually some disturbed kind of thing. You are not able to you are not able to think properly. You are thinking, I want to give answer only. But don't think because interviewer intentionally try to confuse you, but stay with yourself only.
Yeah, okay.
Whatever they confuse, stay with your decision confidently. How much confidence you are saying. So when you confused, right? You were in the middle of the interview. We observed that you are trying to give answer only. You are not thinking what is happening. Also, you are just like okay, I need to give answer. I want to give answer. Answer only important. You are not thinking. Earlier it is very good. You are thinking and giving answer. So that feedback I like to say to you. We can improve next time. So
Okay.
regarding that one, and your way of integration for the systems and way of analysis point of view is very good. So and one more feedback from my side is every time you were thinking to solve the questions in terms of mathematics mostly, not only me, he also said to me some questions you were trying to solve mathematics, that is okay, but first you need to try to solve intuition, like in that point what happened, that the low pass filter question you said, we are saying a lot of them short circuit. Definition of short circuit
Okay.
means both nodes are same voltages, right? So you are trying to go for mathematics, what is happening, you are writing equations. Why? Just
Actually, I
sim
got the answer, but by doing
yeah, yeah,
calculation mistake, I got the
yeah,
one
yeah.
by
What you got the answer,
I
okay.
actually
Simply what I'm saying was
once I once I will
whe-
just
hmm, whether
recheck this, I will
uh,
got the one.
yeah, whether you got the answer or not, it doesn't matter. No one will care. If you got the correct answer or wrong answer, it's fine. But people will see the approach only. They won't care about your answer. They won't care about your answer. They don't expect anything from your side from answer. They only see how you are approaching. Whether your approach is correct, proper, or your confidence. They only see these things only. They won't care about answer. Here, instead of doing very small thing, you are going to equation. So that one feedback I can say, simple short circuit definition. You can see the circuit. First of
Yeah.
all, whenever we will give the question, first see the circuit and analyze from the circuit. What is happening in the circuit? Either it is short circuit, open, whatever. Okay, whatever it is, okay. Just try to analyze from the circuit. Whenever we want any representation, like from graphical representation and exact number, then only we need to go to mathematics. Until and unless we need to try to solve the question from intuition. Like this question you said, right? Last question is very good. You said. I think you, again you came on track, I think. Last you said whenever in second case you said about okay, steady state is achieving, charging, discharging rates are equal. That is very good thought I can say. So again, you went to frequency analysis, low pass filter. It is acting as low pass filter. DC only it will come. Input is a composition of DC plus AC. That is a very good integration of the systems, I can say. We can solve the same problem within 2 to 3 different type of perspectives, right? So when we integrate all the perspectives, you will get to know in which perspective exactly how it is working. So only last and final feedback is don't confuse. People will try to confuse you, but don't confuse. Stay with your decision confidently and try to think first of all. Before giving any statement, just think whether the statement is valid or not. If the person are trying to disprove your statement, then it is very bad. so they can able to disprove you very easily. So that's why whenever you are saying any statement, try to be confident and think before saying statement. And final thing is try to use less mathematics. Don't use mathematics every time. Here also you are using equation 5, these things. Numbers, okay, numbers no one will care. We need to care about why the graph is coming like that, why it is discharging, and why the charging and discharging rates are same. Numbers and okay, we can solve using mathematics. So I think this is from my side. It's from my so only these feedbacks, 3 to 4 feedbacks I am giving. So try to improve from the next time. Okay. Is there anything else?